Hello, and in this video we're going to discuss another measure of position, which is commonly known as a z-score. So to begin, let us define what a z-score is. A z-score of a value x tells you how many standard deviations x is from the mean of the data set. So to calculate it, the z-score of a value x is going to be equal to x minus mu over sigma. And let us only assume that this belongs to a population. I'm not going to define this as x bar and this as s for purposes which I will discuss later. So let us assume that this only belongs to a population. So again, let us consider a data set to exemplify this. So let's assume we have a set of particular weights where those weights are 76, 78, 78, 79, 82, 83, 85, and 87. So I hope that you all can calculate on your own that the mean of the set. So I'm going to take all those values and divide by the number I have. So that's going to be 76 plus 78 all the way out to 87. And I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8 values. That's going to come out to 81. My standard deviation of my weights, so recall, that's going to be the square root of the variance. So the variance is equal to x minus mu squared divided by n. So that's going to come out to 3.61. So if I want to find out the z-score for a particular value, let us assume I want the z-score for 79. So the z-score for 79 is going to be equal to 79 minus the mean divided by the standard deviation. So that's going to be 79 minus 81 over 3.61, which is going to be negative 0.5547. And also note, suppose I want to find the z-score for 87. So that's going to be 87 minus the mean divided by the standard deviation. So that's going to be equal to 79 minus 81 over, not 79, 87 over 3.61. And that's going to be equal to 1.6641 approximately. So what does that mean? So this says that 79 is negative 0.5 or approximately 1/2 standard deviations to the left of the mean. And this value says that 87 is going to be about 1.6 standard deviations to the right of the mean. So how do I know it's to the left and to the right? So our formula is zx is equal to x minus mu divided by sigma. So recall, one property of the standard deviations is that the standard deviation is always bigger than 0. Well, technically always bigger than or equal to 0, but equal to 0 is a special case. But nonetheless, it is never negative. Also, if the value x is bigger than mu, then that means x minus mu is going to be greater than 0. If that is true, then that means the z-score for x is also bigger than or equal to 0. So therefore, what does this mean? So therefore, if x is to the right of the mean, it will have a positive z-score. Similarly, if x is less than mu, that means x minus mu is going to be less than 0. If x minus mu is less than 0, then that means the z-score for x is also going to be less than 0. So that means if x is to the left of the mean, it will have a negative z-score. And also, if x is equal to mu, then the z-score for x is going to be equal to mu minus mu over sigma, which is 0 divided by sigma, which is equal to 0. So if x is the mean, its z-score is 0. Also, you can say if the z-score for x is approximately equal to 0, x is close to the mean. And also, you can say if the z-score for x is really larger than 0, x is far from the mean. Let us demonstrate with another example. So let us assume a set of test scores is given by 69, 74, 76, 85, 87, 89, 93, 97, and 98. And of course, let us assume that this is a population. Firstly, you can find that the mean of this data set is going to be the sum of all our values divided by the number in the set. That's going to come out to 85.5. And the standard deviation of our data set is going to be the square root of the sum of all our values subtracted from the mean squared divided by n. And that's going to be approximately equal to 9.74. So since this is my mean, therefore I can say that the z-score for 85.5 is going to be equal to what? Well, that's just going to be equal to 0, right? Now, if I were to pick a number such as 69, then I can say, well, the z-score for 69 is going to be less than 0. If I pick a z-score for like 93, then I can at least guarantee the z-score for 93 is going to be bigger than 0. In particular, if I want to find the z-score for 79, so 79 is going to be equal to 79 minus 85.5 all over 90.74, which is approximately equal to negative 0.5574. And if I want to find the z-score for 87, that's going to be 87 minus 85.5 over 9.74, which is approximately equal to 1.6641. So from here, I can say 87 is farther from the mean than 79 is. And how can I say that? Well, 1.6641 is farther from 0 than negative 0.5574. So overall, the formula that we're using here is the z-score for x is equal to x minus mu over sigma. And this is assuming that we're dealing with a population. Why is it dealing with a population? Well, because we have the parameters sigma and mu. If we don't have sigma and or we don't have mu, then this formula is going to change up a bit and the interpretation is going to slightly change. But we'll discuss these in a later video, but this is how you calculate z-scores.